Hello, and welcome. Today, we journey to the far reaches of our galaxy to witness a cosmic spectacle, a celestial ghost story that continues to unfold long after its protagonist has faded away. Our destination is about 1,600 light-years from Earth, in a region of space that holds the remnants of a titanic stellar explosion. We're going to explore a mysterious shockwave, an ethereal ripple in the fabric of space, expanding from the corpse of a long-dead star. Imagine a star, many times more massive than our Sun, living out its life over millions of years. It burns brightly, a beacon in the cosmic dark, but its immense size is also its doom. The fuel that sustains it eventually runs out. The delicate balance between gravity pulling inward and fusion pushing outward is broken. In a final, catastrophic instant, the star collapses and then explodes in a supernova, one of the most violent events in the universe. This particular explosion, known as a Type Ia supernova, is what scientists believe happened here. The star obliterated itself, leaving behind an expanding cloud of gas and dust and a dense, smoldering core, a white dwarf. But our story doesn't end with the explosion. In fact, that's where the mystery begins. Astronomers using the European Southern Observatory's Very Large Telescope in Chile were studying this region when they discovered something truly peculiar. It wasn't the remnant of the supernova itself that caught their eye, but something else entirely. They found a star, a survivor, hurtling through space at an incredible speed, over 300,000 kilometers per hour. This star, known as LP42 365, is a piece of the original star that somehow survived the cataclysm. It's a stellar shard, a fast-moving remnant of the white dwarf that went supernova. Finding a surviving piece of a star that completely detonated is a puzzle in itself. It suggests that this particular supernova might have been a bit unusual, perhaps an underpowered explosion that didn't fully disintegrate the star. But the real enigma lay ahead of it. As this stellar fragment speeds through the interstellar medium, it's pushing something ahead of it, like a boat creating a wake in water. This something is a perfectly sculpted, crescent-shaped shockwave. Using NASA's Chandra X-ray Observatory, scientists were able to see this structure glowing faintly in X-ray light. It's a bowshock, a cosmic ripple of superheated gas. The gas within this arc is heated to millions of degrees Celsius, causing it to glow in a way our eyes can't see, but Chandra's can. This beautiful, ethereal arc hangs in space, a testament to the incredible journey of its parent star fragment. Now, a star moving at high speed, creating a bowshock isn't unheard of. We've seen them before. But this one is different. This one is a puzzle wrapped in a mystery. When scientists analyzed the shockwave, they found it was enriched with an unusual mix of heavy elements. They detected high concentrations of elements like neon, magnesium, and oxygen. This chemical fingerprint is a crucial clue. It tells us that the material in the shockwave didn't just come from the interstellar gas the star is plowing through. Instead, it must have come from the supernova explosion itself. It's as if this fragment of a star is carrying a piece of its own explosive history with it, seeding the space ahead with the very elements forged in its final moments. Think about that for a second. The material that makes up this glowing arc was created inside a star, then flung across space in a supernova, and is now being swept up and re-energized by a piece of that very same star. It's a cosmic recycling program on an epic scale. But this leads us to the heart of the mystery, the timing. Supernova explosions are incredibly energetic. The blast wave from such an event should have expanded rapidly, clearing out a vast bubble of space around it. Any debris, any surviving fragments, should be moving within this cleared-out, low-density bubble. In such an environment, it would be nearly impossible for a star fragment like LP42 365 to create a visible bowshock. There simply wouldn't be enough gas to push against. Yet, here it is. A clear, well-defined shockwave, glowing brightly in extras. This presents a major contradiction. How can this star fragment be creating a shockwave in a region that should have been emptied by the supernova that created it? It's like finding the wake of a boat in a completely dry lake bed. It just doesn't make sense. This is where the scientific detective work really gets interesting. One leading theory suggests that the star has traveled a very, very long way. After the supernova, it was ejected at high speed and has been journeying through space for potentially millions of years. It may have traveled so far that it has finally exited the low-density bubble created by its own supernova and is now entering a new, denser region of the interstellar medium. As it hits this fresh, undisturbed gas, it's finally able to pile up material and create the bowshock we see today. If this is true, it means we are witnessing a very specific moment in this star's long and lonely journey, the moment it re-engages with the wider galaxy. Another possibility is even more intriguing. It questions our fundamental understanding of this type of supernova. Perhaps the explosion wasn't spherical. Maybe it was a lopsided asymmetric blast. In this scenario, the explosion could have been much weaker in one direction, leaving a relatively dense region of space untouched. If our star fragment was coincidentally shot out in that very direction, it would have found itself traveling through a denser than expected environment right from the start, allowing it to form a bowshock much sooner and closer to the site of the explosion. This would imply that not all Type Ia supernovae are the perfect, uniform explosions we once thought they were. To solve this puzzle, astronomers are looking for more clues. One key piece of evidence would be to find the supernova remnant itself, the faint, expanding shell of debris from the initial explosion. So far it has eluded detection. If we could find it, we could measure its size and location. This would tell us how far the star fragment has truly traveled from its point of origin. If the distance is vast, it supports the theory of a long journey. If the distance is short, it lends weight to the idea of a lopsided explosion. But finding a very old, faint supernova remnant is incredibly difficult. It's like trying to find the faintest echo of a shout in a massive, noisy stadium. It requires incredibly sensitive instruments and a lot of patience. Scientists are also studying the chemical composition of the shock wave in more detail. By precisely measuring the abundances of different elements, they can create a more detailed recipe of the supernova. This chemical fingerprint can then be compared to different models of supernova explosions, helping to distinguish between a standard explosion and a more exotic, underpowered, or asymmetric one. This single ghostly arc in space is forcing us to reconsider what we thought we knew. It's a beautiful reminder that the universe is full of surprises. The death of a star is not always a clean, simple ending. It can be a messy, complex, and enduring process that leaves behind cosmic puzzles for us to solve millions of years later. The story of LP 42-365 and its mysterious shockwave is a story of survival, of a long journey through the dark, and of a history written in the elements scattered across the cosmos. It shows us that even in death, stars leave behind legacies that continue to shape the galaxy, creating new structures, seeding space with the building blocks of future stars and planets, and leaving behind beautiful, enigmatic clues about the fundamental processes that govern our universe. As we continue to gaze into the deep, we look for answers. Will we find the remnant of the explosion? Will we understand the strange chemistry of this celestial arc? Only time and further observation will tell. But for now, we can simply marvel at this serene and silent spectacle, a glowing crescent in the dark. A phantom wave from a star that is no more, forever pushing the memory of its violent birth across the cosmic sea. Thank you for joining me on this journey to the edge of a cosmic mystery. If you enjoyed this exploration of the cosmos, please consider liking this video and subscribing for more stories from the universe. Until next time, keep looking up.